Morning, everybody. Praise be to the Lord.
Now and forever.
Now and forever.
Okay, guys. To continue with our reviews, we're going to review math. Also, with the same topic about line plots and how to make line plots. The last class, Monday, I think, we already know how to make a line plot, right? And we just are going to review the topic. Okay, so please watch the videos, people, about how to create line plots, right?
In this video, I'm going to cover how to create a line plot. Now, if you don't know, a line plot is a type of graph that uses a number line in order to help us display data. So, on your screen there, we're going to go through this situation and create a line plot together. So, this situation involves whole numbers. I'll follow up this line plot video with a line plot video that involves fractions. I'll drop that link down in the description. But for now, we're just going to work with whole numbers in this example. So let's take a look at the situation. A group of students were surveyed about the number of pets they have at home. The results are below. Create a line plot to display the data. So here are the survey results. Now it's all out of order, so the first thing I would suggest doing is putting the data in order from least to greatest. That way it keeps us a little more organized throughout our process of creating this line plot. So let's start with 0. And it looks like we have 1 here, and then 1 here, so 2 zeros. And I'm crossing them off as I go along. That way I don't repeat anything or leave anything out. And then ones, I have 1, 2 here. So 2 ones. As far as 2s go, looks like I have a few. 1, 2, 3, and actually 4 2s. How many 3s? Well, 1 here and 1 here, so that's 2 3s. We have a 4. It does not look like we have any 5s. And then we have a 6, which is our largest number within that set of data. So now that we have it in order from least to greatest, we are ready to create our line plot. Now here's our number line below. But there are no numbers shown or attached to this number line. So we need to figure out which numbers to use. So let's take a look at our least number, what our smallest number or least valued number is of our data set. Well, it's 0. So we at least need to include that in our number line. And our greatest valued piece of data is 6. So we need to make sure we have the 0 and the 6. So let's start with 0. 1, 2, 3, 4, 5, and 6. So that number line will include all of our data results. Now, you don't need a number line that counts up to 20. That would be unnecessary for the data we have. And you also don't want a number line that only goes up to 4 because you would not include some of the data that you need to have on your line plot. So it's very important to think about your number line and what you need to include when you're setting up your line.
Mr. Can I go to the restroom?
Because that was the smallest number in value that we have, and we ended with 6 because that was the largest number in value. At the bottom of my line plot, I put number of pets right here. That tells us, or whoever's looking at this line plot, what those mean below. And then I also have a title up top here that tells what the line plot is about, number of pets students have. So again, at the bottom, the label tells me what the numbers mean on my number line, and then up top is the title of my line plot. So now we're ready to create our line plot here, and we're going to use X's for a line plot. So let's take a look at our 0 first. How many students have 0 pets at home? Well, 2. So we need to draw 2 X's, and that represents the 2 students that have 0 pets at home. Now, all your X's on this line plot should be around the same size, okay? And they should be pretty well lined up as we go through, and you'll see what I mean as I do number 1 here. So how many students have 1 pet at home? Well, 2. See how I'm starting off my X evenly with the first X from 0? So they are both the same height, right? Because 0 and 1 both have 2 students that have either 0 or 1 pet at home, so they should be about the same size, which they are. How many students have 2 pets? Well, 1, 2, 3, 4. So we need 4 X's to represent those 4 students. 1, 2, 3, 4. Then we check how many students have 3 pets. 1, 2. How many students have 4 pets? 1. How many students have 5? None. So we do not put anything above that 5. And then 1 student has 6 pets. Now that line plot includes all of our students and all of the data that we need to include. So we would be done. We have a title, and we also labeled what the numbers mean on the bottom of our number line. So here we would be done with this line plot. Hopefully that helped. Thanks so much for watching. Until next time, peace. Welcome to Math with Mr. J. In this video, we're going to take a look at a line plot and interpret or read the results of that line plot. So let's take a look at the situation up top. A group of students were surveyed about the number of pets they have at home. The results are displayed on the line plot below. Use the line plot to answer the following questions. So number 1, how many students were surveyed? Well, let's take a look at our line plot here and see what this line plot tells us. Well, the title tells us what it's about, right? It's the number of pets students have. And these numbers down here represent the number of pets. So how many students were surveyed? We need to count the number of X's in the line plot here because each X represents a student that was surveyed. So here we have, for 0 we have 3, for 1 we have 3, for 2 we have 5, for 3 we have 1, for 4 we have 3 students, and for 6 we have 1 student. 5, there's nothing there, there aren't any X's, so no students within that survey had 5 pets. And that's okay if you don't have X's above all of the numbers. So how many total students is that? Well, 3 plus 3 is 6, plus 5 is 11, plus 1 is 12, plus 3 is 15, plus 1 is 16. So how many students? Well, 16 students. We counted the total number of X's, and remember, each X represents a student that was part of that survey. So number 2, how many students have at least 3 pets. So at least means 3 or more. So we include 3. So let's see. Well, for 3 or more, at least 3, we need to look at this portion of the line plot. So we have 1 here for 3 pets, 3 for 4, and 1 for 6. So that is a total of 5 students. Number 3, how many students have 1 or 2 pets? So we need to take a look at this portion of our line plot, 1 or 2. So 3 students have 1 pet, and 5 students have 2 pets. So that's a total of 8 students. And lastly, this is probably the most difficult question out of the 4. How many total pets do the students have? This is not a matter of just counting up all of the x's, because each x, for example right here, each x holds a value of 0, because each of those students have 0 pets. So this is 0 right here. This is going to be worth 0 for that question. Here, for 1 pet, right, we have 3 students that have 1 pet. So those x's represent a value of 1. So I'm going to circle this 3 so we know that the value of that part of the graph is 3. Now 2 pets here. We have 5 students that have 2 pets at home. So how many total pets is that? It's not 5, it's actually 10. Because again, each of those 5 students have 2 at home. So this is going to be 10. Then for 3 pets, we have 1 student with 3 pets. So the value of that x in terms of pets is 3. 4 pets, well, 3 students have 4 pets, so that's a total of 12. And then lastly, we have 1 student with 6 pets, so that holds a value of 6. Now we're ready to count up all of those pets. So we have 3 here, 13, 16, 28, 34. So a total of 34 pets. So there are some examples of interpreting line plot questions that require you to know how to read that line plot and, like the title says, interpret the data. So hopefully that helped. Thanks so much for watching. Until next time, peace. Welcome to Math with Mr. J. In this video, I'm going to cover how to interpret or read a line plot that includes eighths, fourths, and halves. And if you take a look at the left side of your screen, we have a line plot there. And up at the top of your screen, we have a situation that we'll talk about what that line plot represents. And then we're going to answer some questions that go along with that line plot. So let's start up top where it says, the line plot displays the growth of 15 plants over 1 week. Answer the following questions using the line plot. So if we look here at our line plot, we have a title up top, plant growth over a week. And then down below, we have a label for what those fractions and other numbers mean. Those represent inches, so a half inch, 3/4 of an inch, or maybe even 1 whole inch. So let's start with number 1. What was the lowest amount of growth over the 1 week? How about the greatest? So let's take a look at our Now, all of these are fractions. We don't hit on the 0 or the 1 whole, so all of them are going to be a fraction of a whole. So let's find the lowest amount that has an exponent. Each x represents one of those 15 plants. So the lowest is going to be a fourth of an inch right here. A fourth of an inch was the lowest amount of growth over that week. So lowest was a fourth of an inch. How about the greatest? The greatest is going to be right here. Now that does not have a fraction attached to it, so we're going to have to figure it out. So this is 3/4 right here. So it's not 3/4. This hole right here between 0 and 1 whole, this is split into eighths. So follow along with me here. We have 1/8, 2/8, which is equivalent to 1/4, 3/8, 4/8, which is equivalent to this 1/2. We always use the simplified versions of the fractions. 5/8, 6/8, which is simplified to 3/4, and then this would be 7/8, and then lastly would be 8/8, which is 1 whole. So right here, the greatest amount grown over a week would be 7/8 of an inch. Number 2, how many plants grew 5/8 of an inch? Well, again, the eighths aren't marked on that line plot, so we need to figure it out. And I'll go through this again. So here's 1/8, 2/8, which is equivalent to 1/4, 3/8, 4/8, which is a half, and then 5/8 right here. So how many plants or x's is above 5/8? And I'll mark it right here, 5/8. 1. One plant grew 5/8 of an inch. So 1 plant. Number 3. What is the difference between the highest and lowest amount of growth? Well, the highest amount of growth, if we remember, was 7/8 of an inch. And the lowest amount of growth was 1/4 of an inch. So to find the difference, we need to subtract 7/8 and minus 1/4 from that 7/8. Now, thinking back to subtracting fractions, we need an equivalent, a common denominator. And the common denominator for an 8 and a 4 is an 8. So let's rewrite the problem to the side. 7/8 minus, well, I know 4 times 2 will give me that 8, so I need to do the same thing to the top. 1 times 2 is 2. So 7/8 minus 2/8. That 2/8 is equivalent to 1/4, so we did not change the value of the problem. 7 minus 2 is 5, and we keep our denominator the same, 8. So 5/8 of an inch is the difference between the greatest amount of growth and the lowest amount of growth. Lastly, this is the most difficult problem out of the 4. Calculate the total amount of growth over the 1 week. So you're including the growth of all 15 plants. So a common mistake here would just be counting up all the x's and saying 15 as the answer there. But we need each plant's growth added together. So we're going to have to see how much each x is worth. We can think of it like that. Let's start with 1/4. We'll go in order here. So we're going to start right here. And we have 2 plants that grew 1/4 of an inch. So that would be 1/4 plus 1/4. So that's 2/4 of an inch so far we grew. Next, we can skip 3/8 of an inch. There's no x there. So we go to 1/2. And we have 1, 2, 3, 4, 1/2 2 2/4. Now we have 5/8 of an inch right here. And there's only one x there, so that's going to be 5/8. Next, we have 3/4. So 3/4 plus 3/4 plus 3/4. There's three x's in it. 3/4 plus 3/4 is going to give us 1.5 plus another 3/4. So 1.5 plus 3/4 would give us 2 1/4. And then lastly, we have 7/8, right? And we have 1, 2, 3, 4, 5 groups of 7/8, 5 plants that grew 7/8 of an inch. So we need to do 7/8 plus 7/8 plus 7/8 plus 7/8 plus 7/8. I think I got 5 there. So what we can do, I don't know off the top of my head. So let's do 7/8 times 5, which is going to give us 35/8, which now we need to get out of that improper fraction. So how many whole eighths out of 35? Well, 4. That gets us to 32, with 3 left over out of 8. So now we have all the growths listed there. We need to add them up. So I would suggest getting a common denominator right off the bat here. So 2/4, let's use 8. 2/4 is going to be 4/8. I'm going to use 4/8 there. They are equivalent, so I'm not changing the value. 2 1/4 here is going to be 2 2/8. So I'm going to circle everything I'm going to add up because we have a lot going on here. All right, so we need to do 4/8 plus 2 plus 5/8 plus 2 2/8 plus 4 3/8. So I'm going to add all my fractional parts first, which would be 4 right here, plus this 5 is 9, plus 2 is 11, plus 3 is 14/8 is my fractional part, and my whole number part is 2 plus 2 plus 4, which gives me 8. Now we're almost done here. We have 8 and 14/8. We don't want to leave that 14/8 as an improper fraction. It's going to be 1 and 6/8. So I need to combine my whole numbers, this 1 and 8. So it turns out I have 9 whole inches and that fractional part of 6/8, which can be simplified to 3/4. Now I'm running out of room there, so I'm going to go to the top left of my screen and rewrite my answer. I have 9 and 6/8. And again, 6/8 can be simplified. I can divide both of these by 2. And I get 9 and 3/4 of an inch. So 9 and 3/4 of an inch for the total amount of growth between those 15 plants. So number 4 is a common type of problem that comes along with line plots, and it does take quite a bit of work to solve that, but it's just a matter of breaking down the problem and really knowing what you're doing in order to get that total amount. Hopefully that helped with interpreting and reading line plots that involve fourths, eighths, and halves. Thanks so much for watching. Until next time, peace.
This is the last one.
Welcome to Math with Mr. J. In this video, I'm going to cover how to create a line plot that fractions. Now, if you're looking for line plots that involve whole numbers, I'll drop that link down in the description. But for this video, we're going to go over a situation that involves data with fractions, and we're going to create a line plot that represents that data. Now, a line plot is a type of graph that uses a number line in order to help us display data. So let's take a look at our situation, and we'll get into creating a line plot. So a group of adults were surveyed about their shoe size. The results are below. Create a line plot to display the data. So here are the survey results. And it's in no particular order. So what I would suggest would be to put this data in order from least to greatest. That way it helps us get organized and makes the process of creating the line plot a little easier. So we need to find the least valued number within that data, and it looks like it's 8.5. So I'm going to start with 8.5 here, and I have 1 8.5, 2 8.5. So I'm going to list both. That's important for the line plot. Now I'm crossing them off in my original list. That way I don't repeat anything and I don't leave anything out. So next, it looks like 9. So we have 1, 2, 3 9s. Next would be 9.5, which it doesn't look like we have any. So we would jump up to 10, and we have 1, 2, and that looks like it for 10, so 10 or 2 10s here. And then 10.5, which we have 1 here. Then 11, which we have 1, 2. And then 11.5, we have 1, 2 for that as well. Okay, so we have our data in order from least to greatest. So I always like to double check to make sure I have everything. So let's see how many people were surveyed. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's double check our data that we put in order from least to greatest to make sure we have 12 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have everything, and we didn't repeat anything, so we're good to go there. Now let's take a look at our number line here. And it's very important to set this part up correctly. So we need to take a look at our smallest valued piece of data, which is going to be 8.5. So that's where I'm going to start our number line. So we need to make sure we start with 8.5. We need to make sure we include everything. So next, we need the greatest valued piece of data, which would be 11.5. So we need to at least go up to 11.5. So 8.5, and it looks like everything's halves. We don't have any fourths or eighths or anything like that, so we can count up by halves. So 8.5, 9, 9.5, 10, 10.5, 11, and we go up to 11.5. So for this number line, for example, there's no need to go up to 20 for this number line here. You just need to make sure you include the data, the numbers that are in your data. So now we are ready to create our line plot. And before we start that, I just want to mention down here, I have a label. It says shoe size. That's my label for what my numbers mean on my number line. And then up here, I have the title of my line plot. So this is the shoe size survey results. And again, shoe size down here at the bottom is my label for what those numbers mean. So we have two 8.5s. So I represent each number here with an X on my line plot. So I would say 1, 2. And I want all my X's to be around the same size to the best of my ability. So two 8.5s there. Then we have 1, 2, 3 9s. So I need 3 X's to represent those 3 9s. Next, 9.5, which we don't have any. Then we have 10 or 2 10s. 1, 2. 10.5, we have 1 here. 11, 1, 2. And 11.5, 1, 2. And there is our line plot. And we have 12 X's down there to represent the 12 pieces of our survey and our data. So hopefully that helped. Thanks so much for watching. Until next time, peace.
Okay, guys. This was the review from La Line Plot on Friday. We're going to make some exercises on Friday, right? On the board, even in your notebook, right? So I will see you at 11:30 for spelling. Okay. Bye bye.
Bye, Mister. Bye. Bye, Mister.
Bye.